So, hello everyone. Welcome to the Daily Space of Tuesday, September 25th of 2018. I am your host, Dr. Andres Plazas, and today we're going to bring you all the news related to space and astronomy. So, for the first story of the day, we're going to talk about a research in which astronomers actually have looked at the Earth's full natural history and evolution to find templates for vegetation fingerprints. And they were actually looking at how about the different epochs of changing flora show up in different signals, and because we want to be able to determine the age of habitable exoplanets. So the models that the scientists use, they show that the Earth's vegetation reflectance signature increases with the coverage of the surface of the planet, but at the same time also with the age of our planet. So this is a research that was published by scientists from Cornell University, from the Carl Sagan Institute, and published on the Astrobiology Journal. And the basic idea is that we know that the geological record of the Earth for the last 500 million years has shown that the surface of the Earth has changed dramatically. So it was first covered in ice, and then it started being covered in forests spread all over the land. And then the scientists point out that for most of the history of our planet, the land plants did not exist, but the plants eventually became widespread on the surface of the earth. The first plants, or mosses, for example, they only show like a very weak vegetation signature that is actually difficult for astronomers to find remotely, compared to that signature that modern trees give you. So the scientists from this paper, they say that they use the Earth's history as the key for finding new life in the universe. So their work shows that as plants evolved on Earth, the vegetation signal that reveals their presence became stronger, making older exoplanets really like different, like an interesting place to look for type of vegetation. So exoplanets, of course, they could come in different flavors, right? They could be arid, they could come with clear skies, or they could be just hot jungle, like a tropical forest, or it could be whatever. But over these interstellar distances, these places actually might be the best targets to spot this type of vegetation. So one example that we have from our own solar system is that in the 1989, when the Galileo mission left the Earth, Carl Sagan actually requested that the spacecraft's instrument look at the Earth to see how the light reflected from our planet would look like. And then actually observations in 1990 revealed that there was a distinctive boost in the reflectance between the red and the infrared spectrum, just a little bit beyond the limits of the human vision due to vegetation. So this is, of course, another example in which we know or what things should look like. So we actually look at our own planet, and then we hope to find these same type of signatures in other planets. So in the past, we have talked about looking at the atmosphere of the planet, and then how the light from the host star passes through the atmosphere, and then maybe we can identify biosignatures. And then in this paper, then we're also talking about other type of signatures, so the reflectance due to vegetation from um, possible vegetation from a target exoplanet. So yeah, that was the first story of the day. It was very interesting. Another possible signature for to find activity in other exoplanets. And the second story of the day has to do with our interstellar visitor, Oumuamua. Let's try to pronounce that well. That's even a lot of vowels for me. And in this is an interesting story because researchers from the Max Planck Institute of Astronomy, they have actually tracked this object, and they are actually trying to figure out where it came from, like the stellar, possibly the stellar system or the solar system from which came from. And this is an object that was discovered in the late 2017, and as many of you know, this was the first time the astronomers have been able to observe an astronomical object from another star system that is visiting our own solar system. So yeah, well, astronomers actually, how did they do it? So they actually were trying to backtrack the motion of the orbit of this object of Oumuamua. And then at the same time, they were trying to identify the movement of stars in the neighborhood, and then trying to see where those trajectories cross. So actually, people already tried to do this. So I think last year, actually, earlier studies have attempted to do similar reconstructions, but they couldn't find any plausible candidates. So for this study, there was actually a new ingredient. There was another paper published by one of the authors of the current story I'm talking about. It was an earlier paper published in June of this year, in which an astronomer of the European Space Agency showed that actually the orbit of Oumuamua within the solar system is not the object of something that is in free fall. And the free fall is the term that we use for something that it's only acting through the influence of gravity. So like, for example, the planets in the solar system. So these early studies that failed to identify possible candidates, stellar candidates, actually you were just assuming free fall, which is a very reasonable assumption. But then this earlier study that I'm talking about actually found a new ingredient that actually these objects, in addition of experiencing the forces of gravity, um, it was experiencing some additional acceleration when it was closer to the sun. So scientists say, astronomers say, that the likely explanation is that Oumuamua has some sort of similarity to a comet. So it has ice that, when it is sufficiently heated by the sunlight, produces gas that will in turn accelerate this object, like in a very, very weak way, like a very, very weak rocket engine. So it is very weak, and actually this outgassing is not visible on the images when the comet is close to the sun. Like when other comets are closer to the sun. In this particular case, you cannot see this outgassing. But when you are trying to backtrack the orbit of the object, this is an ingredient, or this is another element that becomes relevant in the calculation of the orbit. So in this study, they actually take this particular thing into account when they do their integrations, their numerical integrations to find the orbit, and then astronomers actually were able to have a precise estimate of the direction the object came from originally. And then at the same time, they got an estimation of the speed at which it entered our solar system. So direction and speed are going to be important elements in our story. So in addition, so we have that's our first component. But then what about the stars, right? What about the stars that this object may have encountered on its way? So actually, the scientists used Gaia, um, good Gaia that is producing a lot of data. And they used the data release number 2 of Gaia, and they used the precise information about positions on sky motion and parallax as a measure of distance for these stars for about 1.3 billion stars. And then for 7 millions of those 1.3 millions, they also have information about the star's radial velocity, and then that is to say if there is the motion that it's directly away, or that is moving directly away or from or towards us. Um, so yeah, well then after the astronomers did all these calculations, and then they were able to actually identify the 4 candidates. One of all of these four candidates are dwarf stars. Like there was one candidate that came closest to Oumuamua about 1 million years ago, and it's a particular reddish dwarf star, and they were able to determine that this object approached this star within about 2 light years. And given the uncertainties in the story, this is a distance that is close enough for a scientist to be able to posit that Oumuamua originated from this particular planetary system, if there is one planetary system in this star. However, the other element, as I was mentioning before, is the speed of the object, and they were able to determine that the object had a more or less large relatively speed, around 25 kilometers per second, when it was passing close to this star. That makes it less probable for it to be the home of this planet. So why do we need like a smaller speed? Because they are working under the hypothesis that there was some sort of perturbation, gravitational perturbation. If this object came from another solar system, they're thinking that it got ejected from that solar system due to some sort of perturbation or something. But scientists think, astronomers think that the speed at which an object gets ejected from one of these solar systems or planetary systems should not be as high as they have observed. So I just mentioned one of the possible candidates that they have found. In particular, they have found four candidates. Some of the candidates have like a long, greater approach speed, but with a smaller velocity. So in the end, these are just plausible candidates, but still not like a smoking gun actually to tell us for sure that this object came from one of these particular systems. So, well, they're hoping that using Gaia's third release, the data release is going to happen in 2021. The study should be able to determine with greater precision the orbits and the speeds of this object. Because despite the fact that Gaia already gave us like a lot of data, this study is particularly limited still by the number of radial velocities that you can find in the second data release of Gaia. And yeah, so that was the second story of the day about the candidates and about the possible origin of Oumuamua. And there's something that would be very interesting, something we would like to find out where it came from, to learn, of course, more about other planetary systems from different from our own. And then for the final story of the day, we got some stories from some news from JPL, and in these studies, actually, the researchers report using data from Cassini that they believe that there are likely dust storms on Titan. And if this is true, then it would be the first time that this particular type of dust storms are spotted on this moon, on this world, on Titan. So as I was mentioning before, they used data from Cassini to identify giant dust storms in the equatorial regions of Saturn's moon Titan. This is a discovery that was published yesterday on Nature Geoscience, and it would make Titan the third solar system body in addition to the Earth and Mars, where dust storms have been observed. So this is an observation, of course, that is going to help us to better understand the dynamic environment of the largest moon of Saturn. This is a very active moon, so there are already certain similarities with respect to the Earth. So, for example, well, there's geological activity, and now scientists say that this would be another analogy with Earth and Mars, this active dust cycle in which this organic dust can be raised from large dune fields around Titan's equator. So, well, Titan is a very special world, right? It's in some ways it's similar to the Earth because it's the only moon in the solar system with a substantial atmosphere and the only celestial body other than our own planet where stable bodies of surface liquid are known to still exist. The thing is that, of course, we have water in on the Earth, whereas in Titan, actually, we have rivers of methane and ethane that flows through these reservoirs. So scientists, well, they know, of course, that the weather on Titan varies from season to season as well, like in the Earth, and in particular around the equinox. But then, in this particular study, the scientists first spotted three unusual equatorial brightness in the infrared light, in the infrared images taken by Cassini in about 2009. And well, at first they thought that might have been some sort of kind of methane clouds. However, they were able to actually rule out that this type of dust clouds that we're observing, that they were able to rule out that they were just something that they already knew and actually could figure out that it was something consistent with dust storms being lifted from the ground. Um, yeah, so just to finalize, for with one of the comments of the scientists from the study, they say that when the Huygens probe landed on the surface of Titan in January 2005, well, they believe that, of course, this probe actually raised a small amount of organic dust upon the arrival because of the powerful aerodynamic wake. But what they have spotted today with this data is at a very much larger scale, and they say that they conclude that the surface wind speeds or the near surface wind speeds required to raise such an amount of dust as they see in these storms, they will have to be very strong, about 5 times as strong as the average wind speeds estimated by the Huygens measurements near the surface and what scientists can estimate with climate models. So, of course, this is also telling us that this underlying sand could be set in motion and that the giant dunes covering Titan's equatorial ringes are still active and continually changing, that it's a dynamic environment. So yeah, that was the third story of the day what I wanted to tell you for today. So I'm gonna see if you have any comments or any questions, and I hope that I wasn't too faint. I didn't have the right microphone today, but we made it work. So hello everyone. I'm gonna say hi to the people who are commenting in the chat. So I see Richard Hendricks. Hello. I see Bad Panda Bear. I see Ironheart, DPI, Fenring. Hello. Hello, Larry. Hello, Guido. Uh, hello, Susie. And is that the Pangea in the middle? Might be it. Maybe you're referring to this first picture. Uh, it has different names depending on the supercontinent. It has different names depending on the geological time. So I don't remember exactly at what point in time it was called Pangea, but it could be. So yeah, I'm not still sure about that one. Hello, disillusioned. Hello, Tom. Hello, Honey. So Honey's asking, is there any type of correlation between the color the plants chose to reflect and some quality or the light from the sun between the color of the plants? I don't understand that. Some quality, or let me see. Let me read it again. Between the color the plants chose to reflect and some quality or the light from the sun. I am guessing a planet just getting plant life would always have coloring starting at the edges of the continents. Why would you get that? Like some sort of coloring due to seasons or what? I'm thinking that's what I'm thinking right now. So I'm a little confused about that because, of course, well, we have variation, intrinsic variation in the coloring of the plants, but in some latitudes of the Earth, we have some variation with respect to the coloring, which I would think would affect the type of reflectance of the light that you get um, from the sun. Let me see. Are they looking for relatively new systems or an older system? I think they're looking for relatively older systems because they were saying that you should not be able to see such a strong signal with a relatively younger system. And of course, this is the usual assumption that things are working the way they work here on the Earth. So in this study, of course, they also look at what happened with the Earth, and they conclude that actually that the reflectance signals should be larger in an older planet than in a younger planet. Do they say what the dust is made of? Is there any normal dirt on Titan, or is it something weird? Titan does have a thick atmosphere. They actually don't mention that in the press release, and that's a very good question. And yes, I don't know exactly the answer for that right now. So it would depend on the type of I would think the material, of course, that constitutes that particular dust. But one of the things they do mention, I think, is they're talking about methane storms. But this is one of the things that they were trying to differentiate. So this is different, of course. They see that we already knew that you could find massive clouds that could form in tropical regions and cause powerful methane storms. But yeah, that's different from what type of material is that dust made of. So I don't have the answer right now. So yeah, I will have to double check that. But we have a few more minutes. Maybe I can figure it out. But do you have any more comments or? Sorry, I have like two computers in front of me and three screens because I had to improvise a little bit with the microphone. Just yeah, I'm looking soft wet sand. Yeah, what I find is I didn't find exactly what it's made of, so I will have to check with more time and more calm. Probably they have an educated guess of that, but yeah. Okay. Do they means not? Yeah, that's what I was. I'm just looking at it. Maybe I'm just googling it because I don't know the answer. But one of the things that I found is like wet sand somewhere. Yeah, in one of the studies they say it is like snow that has been frozen on top. So they mention in one of the articles that I found is like the fact that Huygens bounced and wobbled rather than simply splatted suggests that the moon's surface was dry when it touched down. But then uh, they also see evidence of the from the Huygens landing data that there is a fluffy dust-like material, mostly likely organic aerosols that are known to drizzle out of the Titan atmosphere. All right. So methane or ethane rain, which pulls into huge lakes on the Titan surface. Okay. Oh, all right. That's what I could find for now. But yeah, thank you very much for the question. That was pretty cool. Yeah. Um, so Tom is asking something related to our event that we had yesterday, just switching a little bit of gears. We organized for the first time our first Astronomy on Tap event in St. Louis. So this is an international event that started in about 2012 in New York, and many of you may have heard of it, maybe, where astronomers give informal talks in bars to people. No, and the idea is just to bring science to our communities. And I used to help organize this when I was a postdoc in Pasadena, in Los Angeles. And then when I recently moved to St. Louis, where I am currently now, I thought of the idea of starting Astronomy on Tap, and we had it yesterday actually. And yeah, we had about 38 people. It was a good turnout, and Dr. Pamela Gay was one of the speakers, and one professor from Washington University in St. Louis. So that was a lot of fun. And if you have maybe wherever you live, if you see one of these events, I encourage you to attend. It's pretty cool. But thank you for asking. Hani's asking, is it cold enough on Titan for water ice mountains like in Pluto? Oh, that's a good question too. I don't know the answer for that. What I'm guessing is like, well, yeah, we're beyond the frost line in the solar system, but at the same time, you have some atmosphere that is some sort of somehow regulating the weather. But it does get pretty cold. The average surface temperature on Titan is minus 290 Fahrenheit, which is very cold. So that could be plausible. Very cold, yeah. It's not a very hostile place for humans in the solar system with all these methane clouds and this very cold temperature and very far. It is very, as I said, it is way beyond the frost line. So, but on the other hand, there is the atmosphere. So anyhow, um, yes, not very hospitable. All right, everybody, thank you so much. I think I am gonna go, but I am very thankful for you always showing up. And this has been the Daily Space for today. It has been brought to you by CosmoQuest, a project of the Astronomical Society of the Pacific. So give us a like if you want to support us, because those are free, but even better if you want to subscribe, that's even better. And we'll be back again tomorrow with all the news from space and astronomy at 1 p.m. Eastern Time. And yes, have a great week. See you all. Bye bye.